Can I start? Oh, good. Hi, everyone. Thanks for coming. I just heard that the happy hour started, so I see you as the people who are really in here for the Web3. For everyone joining us on the live stream and don't see the crowd, there's like around 1,000 people in the crowd. So again, everyone thinks, yeah, that person was 1 mile away. Anyway, so the title of the presentation is Battling Anxiety, and I know this wasn't actually in the schedule this way. Alternative ways how I like to talk about this is how I started to love using Web3 and stop worrying, or how to make people feel more comfortable while doing Web3. But before we start, I know there's not a lot of us here, but let's start with a little exercise. So I'm going to say a thing, and if it applies to you, please stand up. And then please keep standing up until I finish this whole thing. My speaking coach told me it's very, very, very important to get people moving for the presentation. So if you're a signer on a multi-sig, please stand up. If you ever sent a transaction on chain that failed and cost you like 15 bucks or 10 bucks, can you please stand up? Okay, cool. So I'm trying to make everyone feel anxious. So if you were in a situation where you did a swap or did something on OpenSea and the prices varied greatly from what you expected it actually to be, can you please stand up? Cool. So half of the crowd, which isn't a lot, stood up, but this is, you can sit down. And thanks for following instructions to the point. But why did I start with this? So today we're going to talk about 4 very vague sections of this presentation, and they're vague by design. But it's basically, there is a problem that we're not tackling before a transaction is sent. So I'm not talking about the user signing the transaction. I'm not even talking about like how it ends up in a mempool or whatever. And we're going to see what I'm actually talking about here. We're going to be talking about the solution. So we're going to focus on a particular problem that I'm going to talk about, and we're going to see how we can tackle this specifically. The third one, we're actually going to look at how this looks in the wild, and probably some of you in the crowd actually were using already something like this. And the last one is the most technical part of the talk itself. It is how you can actually implement this. So without further ado, and actually being extremely vague. So before a transaction happens, we usually talk about education. We talk about a lot of different things, but basically we can divide this into 3 different parts. So the first one is making smart contract development easier, more accessible, more secure. Here comes your truffles, hardkits, foundries of the world. Here come your audits. Here you can also have, for example, the educational material used for developers, how to write secure smart contracts, etc. The second one, which I think is tackled the most, is actually educating a user. So someone comes to Web3, whatever, and then like what's a mnemonic, how to send the transactions, etc. The third one, which we're actually going to talk about, and here by design, it's very long again to make you feel a bit more anxious. And I'm probably going to screw this up. I didn't practice enough, but helping developers as well as retail users know what will happen before writing something into a ledger that will be there until the end of time. So let's remember, something that we send on chain, it's there forever, or until blockchain dies, but we hope forever. But the third one basically is simulations. So today we'll be talking about simulations and how we can use simulations to make users more safe. And we're also going to tackle how you can do this yourself without using like an external party or service. Anywho, let's start actually why Web2 sucks. Every good Web3 presentation should start with how the olden world is crap and how we're building the best thing. So a couple of months back, I wanted to make a purchase. Now, I come from Republic of Serbia, and we have something called the Serbian dinar. It was a very inflationary currency during the 90s. So for example, a beer costed a couple of million Serbian dinars. Anyway, a couple of months ago, I wanted to make a purchase, which was 1,400 bucks. Now, the currency exchange ratio for the Serbian dinar is usually $1 equals 116 Serbian dinars. So I went to my banking app, checked the currency exchange ratio, and like everything was completely fine, everything was working. So I didn't click in the app to exchange the money. I swiped my credit card online, and in the bank statement, what I did expect was for 162,000 Serbian dinars to be charged. So that's like 1,400 bucks. But the notification in the statement itself said it was 170K. So I thought, like, what the fuck? Like, where am I missing? Why am I missing this money? And what happened is basically slippage. So what happened? 6 years ago, when I was opening my bank account, and the bank is a great friend of mine, I basically signed, if I do the currency exchange by hand, I get a good exchange ratio. If they do it automatically, there is slippage. They take like 3 or 4%. So that is crap. I didn't know, I didn't read. Like, who reads like 60 papers to use a bank account? And we can kind of look at the same analogy for smart contracts. Like, did you actually read all of the Uniswap contracts? No. Anyway, so how can Web3 make this better? So, same inflationary currency, the same purchase, same currency exchange ratio. But let's imagine I'm using a browser wallet for this. I go, I want to make the purchase, and my wallet says, stop. This is 170K Serbian dinars. Are you sure you want to send this transaction? And I can say, hey, this is more than what I signed up for. This is like 80 bucks more. I can go to my app, do the swap, and that's it. So basically, the profit that I get is the 80 bucks that I didn't lose. Also, banks suck. It's also a very important thing to say here. But the consequences of not knowing what would the transaction do before sending it are manifold. So good examples that happen in the wild, or maybe bad examples that happen in the wild. For example, there was a 1.7 million OpenSea phishing hack where people thought they were buying NFTs. They were actually just sending them to other people. DNS hijacking, so someone can hack your front end and put malicious smart contracts to be contacted instead of the real ones. Blind multi-signing, we're going to be talk about this a bit more. And implicitly, I think a thing that's not tackled at all is that a lot of very, very smart people that we could very, very much so use in this space to make the space better think Web3 equals scam, and that's it. And we especially see this when hiring people from Web2 to Web3. I'm going to stop so you can take an image. This is an interactive show. Anyway, no, I'm joking. Anyway, so hi everyone, my name is Bogdan. I come from a company called Tenderly. We're a developer platform. It has a bunch of tools and services helping blockchain developers, debugging, profiling, monitoring, alerting, a bunch of different stuff. But the thing that we definitely heard here today, and we have a booth, is that most of the people are using our simulations in this space as we were the first ones to make them. So we're going to be talking about the solution to the actual problem that we have been talking about. So what does this actually mean? Let's extrapolate this point in time 10 years into the future. So let's say that we want to have safe and transparent transacting be a basic human right. Just as the access to internet, just as access to monetary things is a basic human right, we should know what we're signing up for. We should know which transactions we're sending. And this goal is much larger than a single company or a single product. I'm very glad that some people are joining the simulation space, although 2 years later. And also democratizing this data was what got most of the people into this space itself. And I'm glad more people are thinking about this. But let's go very concretely. So what's the goal of this presentation? Before sending a transaction, how can we know what events will be emitted? How will the state change? Which functions will be called? So the keyword there is will, in the future, of course. So what do we need to achieve this is a 4-high-level node, custom state management, and custom execution. So this was the teaser for section 4. But let's talk about a real case study. So multi-sigs. Who here knows what the multi-sig is? Just so I know. A couple of people. OK. So for a couple of people who didn't raise their hand, very briefly, very high level, multi-sig is a smart contract wallet where multiple people have to say, hey, this is good for it to actually send it on chain. I kind of lied here, but I think I got the gist of it. So there are a lot of moving parts when using a multi-sig. Multiple people have to say this is OK, so we can have human error. Doing a couple of things in one transaction. Multi-sigs usually do like 10, 12, 14 transactions in a single transaction. So I can do a Uniswap swap, pay all of the employees inside of Tenderly, do something in Gitcoin grant. So these things are very complex and have hundreds of smart contracts interacting. They usually have a lot of funds locked inside of them. So they're usually managed by DAOs, VCs, or companies. So there's a lot of money locked. And finally, the last one is it can be time sensitive. So this is kind of the human error part. Let's say, for example, I'm running an engineering team. We find an exploit in 3 a.m. I wake up everyone and say, guys, please, please, please sign this quickly. And they cannot even know what will happen. So why did I mention multi-sigs? Let's look at a real case study of Safe, or X-Gnosis Safe. So for anyone who didn't use it, Safe is the most widely used multi-sig. You can say in the world, it's interesting now. But yeah, most widely used multi-sig in the world. And it lets you do a bunch of interesting things. But the one that I like a lot is something called Transaction Builder. So coming back to my example of doing a Uniswap swap and then paying out everyone in the company and then doing something else, you can basically chain these transactions together, and then instead of sending 10 transactions, you can send 1 transaction on chain. It looks like this. So by a show of hand, can someone tell me what this transaction does, or what these 3 transactions do? Correct. You can't. Anywho. So for people on the live stream, the silence was barely bearable. So what the Safe team actually came up with as an idea is to put the simulate button at the bottom right-hand corner. So what they do is I come up with these 3 things, these 3 ambiguous things that nobody here in the room, me included, who did the screenshot like 4 months ago, and you can click simulate, and what you get back is basically a result. And this will say, hey, this transaction will probably fail. Do you want to actually send it? So this can prevent me, first of all, spending $100 on gas as an example. But another thing that's very important, what's worse than a transaction failing is a transaction succeeding and doing the wrong thing. Coming back to the anxiety inducing, it's in the ledger forever. And from there, they can basically click and see this is Tenderly, which cannot be seen on this projector, but you have to trust me, there's a very nice UI here, which shows you what exactly is happening in the transaction. And at the top, I can see that the error message like Uniswap invalid path, so that usually means I screwed something up integrating with Uniswap. And then if you're a developer, you can do an even deeper dive and like figure out what was happening in the transaction. This was a small Tenderly shield that just happened and you weren't aware of it. Anywho, so what are the benefits of what the safe team got actually by integrating simulation? So every signer knows what they're signing. So that situation where I wake up someone in 3 a.m., they can actually in a minute know what will actually happen. You don't spend money on failed transactions. That one is quite straightforward. You can see the complex smart contract interactions that are actually happening. So let's say, for example, I touch Uniswap 1 inch and, I don't know, a Chainlink Oracle. That will be around 200 contracts participating in one transaction. This is the best way to reason about these complex interactions. And finally, if the transaction is executed in a later time, we can be sure that the results are still going to be the same. What do I mean by this? I can schedule a transaction and say, hey team, sign this whenever. And the last person who is signing it 7 days later can still make sure that the intention I had 7 days ago is still going to happen on chain. So how did they actually do it? So they needed to do a couple of things. The first one that they had to do is impersonate the person who's actually signing the transaction. So we need a way to basically fake who is sending the transaction, and they can do just that. They can send transaction as anyone. They need to provide the transaction input data. That one is quite straightforward. Then how multi-sigs work. If it's like a 5 out of 7 multi-sig, that means that 5 people need to say, yes, this is good for it to actually happen. And what they do is something called a state override. So they can lower the number of signers needed so the transaction passes. So they can literally lie to the smart contract in the simulation saying, hey, you only need 1 signer for this thing to actually pass. And finally, you need to combine all of this data and serve it to the user with the current chain state. So how does this actually work under the hood? Coming to like very, very detailed Tenderly shilling. But this is our simulator. I'm going to tell you how you can build this yourself. So it's not the full shill. But on the left, I basically have the DAI smart contract selected over here. And I want to send myself some DAI in a simulation. Now, you can see I pick the transfer function over here. I pick my wallet as the destination. And I say I want to send 1,000 units of DAI to my address. Now, I think I know here is that the wallet I'm sending this DAI from doesn't have any DAI. So the transaction will fail. But taking back the example of the state override, so changing the signers, a thing that I can do for this transaction is I can change the state of the DAI smart contract and I can suddenly mint myself 10,000 units of DAI so I can make sure that this transaction will actually pass. When I submit it, this is something that never touched the chain, but I can see exactly what would happen if I send it. So how can you actually do this yourself? So the first thing is you need something like akin to a custom EVM. You can do this by, for example, forking Geth, forking Aragon, stripping it, ripping it, and basically putting your code inside to instrument the VM to know what's actually happening inside. The next thing that you can do is custom state management. So if we remember, we have the current chain state, that's what's actually true on chain, but the next thing that we actually have to do is take the user's input, for example, the state override I did for DAI right now, and basically merge those 2 states, the one on chain and the one that we're basically lying the virtual machine the current chain state is. Custom execution, so we have the custom EVM, now we have that state that we're gonna put underneath the EVM to lie to it, and the thing that we have to do is run the whole execution with that custom state, and generate some data that we're going to use to actually surface this. And then finally, what we saw most people find useful is returning events, state changes, function calls, contra calls, and gas information. And there is so much more that you can actually do with a bunch of these things. So for example, if you do simulations over Tenderly instead of building your own, you have an API access. A lot of things that you use in this space you aren't actually aware of doing simulations over Tenderly. For example, I really like the safe integration here, or for example, InstaDApp. When you go to InstaDApp, you can click simulation mode and use InstaDApp in a completely gasless way to test out how the DApp actually works. You can do a staging environment, so instead of running a local node and clicking everything on your computer and forking a mainnet node, what you can do is just by one click spin up a simulated cloud environment and do all of your staging things over there. You can do integration testing, which is basically running all your tests in parallel. You don't have to test in production. You don't have to test on Arbitrum. You don't have to beg for Goerli ETH. And basically, you can do all of these things free of charge. You can do bug fixing. So if we can use simulations to see what will happen if I send a transaction on chain, we also can do what-if scenarios. So how would this transaction behave from a month ago if I actually change some parameter, change the input parameters, change the source code, change the state of the smart contract itself, and figure out like if a bug fix that I wrote would have prevented the bug in the first place. And you can also do a bunch of like generalized bots and a bunch of other different interesting things on top of this. So it's a very generic primitive, which we see more and more being used in the space for very cool stuff. Anywho, thank you so much. We have a booth over there with a very, very fun Minesweeper game which showcases simulations. I think it's a very nice way to reason about it. We also have a bunch of swag, and we love to talk about infrastructure developer tooling and Web3 in general. So please join us there if you want, and thank you so much for your attention.